In Chapter 5, we have some instructions for beginning charts. To do this, we're going to use an older procedure that's within the SAS-Graph product, and we're going to use the procedure called G-Chart. G-Chart has some wonderful capabilities. We'll learn just the basics here in Chapter 5, and then later in Chapter 17 we'll learn some enhancements to the G-Chart procedure in terms of color and symbols and that sort of thing. So at this point we're just going to let SAS pick some default colors for us, but we can do some beginning things for creating histograms and bar charts outside of, say, univariate, which we saw could produce histograms for us. So to do this, we're going to need the G-chart procedure. So whenever you see a procedure that begins with, say, the letter G, it means it comes out of the SAS-Graph product. So, or the G procedures. So there's more than one graphics procedure. When we look at the G-chart procedure, the syntax here, there are other statements we can look at. We're going to look at V-bar and H-bar for vertical and horizontal bar charts, something called a block chart, and a pie chart. So we'll just touch on these each a little bit briefly. By and where statements are optional statements, and these are optional statements for virtually all of the procedures we look at. Again, if you have a by statement, that means you have previously sorted the variables indicated in this by statement, and so you have a compatible sort for your specified SAS dataset. Likewise, a where statement can be used, and we looked at the where statement and how to construct the syntax for a where statement in Chapter 4 in Data Step Information 2. Each of these graphics statements here have various options available. Some options work for more than one of these types of charts, and so we'll look at a table in the book that helps it summarize what's available for each one of these particular types of chart statements. Table 5.1 on page 78 is where this summary is done, and so that for the horizontal bar charts and the vertical bar charts, we see that a lot of the options are the same. Block charts are more limited in the options that are available there, and the availability of options for the pie chart then is this even shorter list. So standard options that control number of bars, number of wedges in a pie chart, that sort of thing, what kinds of axes are available for us, and then we'll look at in this chapter group. We won't get into subgroup and really until Chapter 17, but when we look at Chapter 17, I'm not going to repeat this table, so this is the place to come back to look at the available options. You can do some summary analyses in here for either of the bar charts, and so statistical analyses can be printed. There are some general ways to control the chart appearance, if you want reference lines, if you want headers, do you want spaces in between the bars, etc. And so all those are listed here in table 5.1 on page 77 in your 78 in your book. Each of these options is summarized, and some syntax examples for these options are given in the text that follows this table. So to illustrate some of the different types of charts, we're going to use the instruction data set that we introduced in section 3.2. That's listed here on our SAS screen. And then we'll look first at Objective 5.1. Just look at what we get for a default vertical bar chart for number of students in each program. And so that is, we just want frequencies of each program printed, and so that we don't have any options on the V-bar statement. Again, I can use as many lines of title or footnote as I want. This is the beginning of a SAS session, and so the instruction data set has not yet been defined in this session, so I have the data step picking up the instruction data set as we were initially given it. So we submit this program. Take a quick look, at the log. We did see an image there before I did that, so we don't detect any errors here, so we can move then to the results viewer. So without knowing it, we've gotten fonts in here that are without serifs, and we have boldface in the titles. We have a frequency bar chart. It's chosen blue here for us for the colors of the bars, and so this is what we get by default. Our program in the VBAR statement, the program is referred to as the chart variable. The chart variable, and we're counting looking at each value of program, and it measures the frequency of occurrence. So that's why we see this vertical bar here, or the vertical axis here, measuring frequency. We can have the height of the bars determined by something other than frequency, but that is the default. If we would have had our input statement in the creation of our data set where program and score had a proper case, that is a first letter that was capitalized, that would look a little bit better in terms of the labeling on our graphic here. Older versions of SAS pick different colors, so here we kind of have this medium blue color for the bars, and so we'll learn how to change that a bit later in the book. A couple of things to note here. Program was also a character variable, so it did put things in ascending order here in terms of the number of bars, which that would be alphabetical. If we had put in values 1 and 2 for program, then whenever I created the data, if this $ would not have been here, then the program would be numeric. And I'd have to be careful there because the VBAR statement in the G chart procedure is going to print more than just 2 bars. And so I call your attention to the discrete option for that, and so you may want to make sure you look at the notes on the discrete option in the textbook. In our second objective of Chapter 5, we're supposed to produce 2 vertical histograms for the number of students in each program. We include a title. Okay, so that we can do this a couple of different ways. So we first say then we want a chart for each program, or say by this. So what we're looking at when we talk about a histogram for score here, notice score is this numeric variable, and if we put space equals 0, that's in order to produce a histogram. Because our default bar chart, it puts spaces in between bars for a histogram. Recall we want the bars to look like they're centered over values on a continuous scale. I want to do one of these charts for each program, and so I have a by statement then here to do this by program, and so I need to sort by program and then run the chart procedure by program. And so since we've already created the SAS dataset instruction, I can just pick up this code. So the space equals 0 then omits the spaces in between the bars. It's still frequency, and so it gives us these midpoints here that appear every 6 points apart for program B. And if I scroll up to program A, I end up with a different set of midpoints than I do for program B. I also have a height here on the vertical axis of frequency 4. Here I have frequency 6. So that by statement, I don't get uniformity in the output from one chart to the next. Vertical axes are not in agreement, neither are the horizontal axes in agreement. So we might want to look at a way as can we fix that so that they both look the same way. So that is, if we were to look at these images side by side, they have the same scale. Now we can redo those charts in Objective 5.2 where we control the scale for the vertical axis and as well the number of bars on the horizontal axis and where they're centered. So here is, we still want the space equals 0 option to produce a histogram. The axis, this refers to the vertical axis on a vertical chart, that it's going to have height go from 1 to 6. And so you look at the different syntax options for syntax that are allowable for the axis option. This is one. midpoints, you can list the values that you want for the number of bars. And so here I have 1, 2, 3, 4, 5, 6, 7. 7 midpoints. If we pop back over for a second, it generated 5 bars on each one of these. And so SAS was in charge, or SAS picked where I centered those bars. So let's come back here. The data has already been sorted by program, so I don't have to repeat that, but I can just execute this code. Okay, now then I have 7 bars, and so we notice the shift to the right here in program B. Since that's where it ends, we're just the reverse here. We have this vertical axis here, and we can see that we have some smaller scores here available in program A. None of them occur with this strong frequency that we saw in B, but this allows us then from chart to chart, I have the same midpoints in program A as I do in program B, and I can see then the shift to the right or to the higher scores in program B. Now, instead of having these two on different sets of axes here and scrolling back and forth, or otherwise copying these images and putting them side by side, can I get SAS to do a little bit of that for me? Okay, so I'd like the midpoints. I like it shows the shift. The axis I like, all right, but I'd like for them both to be on the same axis. So how we do that is what we're instructed in Objective 5.4. We have a new option here. It's the group equals program option. You can put spaces around the equal sign or not. That's your choice. And so that here group has 2 levels, so I'm going to get then a histogram, since it's space equals 0, for program A, and a histogram for program B on the same set of axes. So if I highlight this part and submit this code, it breaks it up into 2 pieces. So the effects of that group option is down here at the bottom. Okay, and so if we would have had, say, 5 different programs A, B, C, D, and E, that could get very congested or compressed if we were to try to put all of that into one image. But now then, visually, side by side, we can see the same vertical axes. We have the same points down at the bottom. Now, if I had not used the axis option and I had not used the midpoints option, SAS would have picked the midpoints for me. The midpoints might not be what I like, but they would be the same from one program to the next. Here, doing these things in increments of 5 seemed like a good idea. SAS would also set, then the frequency would be set by the tallest bar, which in this case was frequency 5. In addition to a vertical bar chart, we can also look at a horizontal bar chart. Here I have no options, and I'm just going to look at what's the default information. Picking up these 3 lines of code and their run statement, I submit those. So I get horizontal bars. Horizontal bar charts, it wants to print some summary statistics over here to the side. That is, what is the frequency, the cumulative frequency, assuming then the things are in order. Here, the percent of the data that is in this column, and then what the cumulative percent. And so that we can see for the SAS selected midpoints. Okay, these are now by 8, and it did choose 5. It's not a histogram. Remember, histograms, we need the spacing in between the bars. Okay, so that's the difference between the horizontal bar chart and the vertical bar chart, really, aside from the direction, of course, as the appearance then of these statistics at the side. So if we want to make the correction here, say no spaces in between bars to make this truly the appearance of a histogram, and choose perhaps not this number of bars, but suppose we only want 4 bars, and if we don't care to have this on our histogram, so all these statistics, we can do that, and that's what Objective 5.6 does for us. In Objective 5.6, we keep the say use space equals 0, that is, make it a histogram. Levels equals 4. I want 4 bars. I'm letting SAS pick them. So that doesn't give me the control that the midpoints option has. It gives me more control though over using no selection for midpoints. No stats, that means that information that was printed off to the right, I'm asking it to suppress. The other thing I want is I'd like to have some kind of reference line drawn to tick marks down here on this horizontal axis here, so as a visual aid. And so I can do that auto ref and clip ref together, kind of make them appear in the background. Auto ref says place them at the tick marks, clip ref says move them to the background. Okay, and so we'll choose this. Okay, and we can see that those reference lines in there now, because whenever if we had very many bars, it might be hard for us to see where their height measures on the frequency axis. Notice we have a kind of a little bit of a gap in space here whenever we have few bars, and that there's a broad bit of space. Now in the textbook I edited that image and compressed that space or removed that space in there for the purposes of the printing of the textbook, but that is something that you would probably have to learn how to edit graphs for. So editing the graphs are not the goal of this chapter, but we could see that in some of these instances where that might be necessary to remove blank space here and then again down below. Back in our first objective of Chapter 5, we were just looking at with what frequency does each program occur, this classification variable. There it makes sense to have a bar chart or space in between the bars. But suppose I'm not interested in, well, just how many are in each group. Maybe instead I have this other variable score. I'd like to know what the average score for each program is and have a graphic of that. And of course then if I had more programs, I would have all of these bars that are the height of the mean printed side by side. Well, how can I go about that? That's what Objective 5.7 does. As it says, okay, we're going to illustrate this using a horizontal bar. We could just as likely use a vertical bar chart. New commands here or options on the H-bar statement, also available on V-bar. Double check things in table 5.1. Type equals mean. That the default is type equals frequency or freak. So we already know what it's doing there. And so type equals the mean, and so we have to tell it the mean of what? The mean of what variable? And so that's what sumVar is, a summary variable. Which one are we summarizing? And then the mean then is print that statistic at the end of the bar. And so you can look at the mean option is one of the options then on the H-bar statement. So we grab all these lines and submit those. Okay, so now then score mean, that is the height of the bar for each program. These over here are the result of the mean option. The type equals mean, sumVar equals score, produces bars of this height for each program. Notice we have a wide blank space here again, like we did in the previous horizontal bar chart. We could do this using a vertical bar chart. In fact, we can go off script here from what the book's doing a little bit. If we put a V in here for V-bar, we can get a similar looking image. And so here it printed the stat inside of the graph rather than outside of the graph. Now I didn't list them as statements for the G-chart procedure, but there's a V-bar 3D and an H-bar 3D that produces three-dimensional charts of each of those types. And we also have something called a block chart. And so 3D options, just because we have a 3D option doesn't always mean we should use it. So notice here I have proc chart and I have V-bar 3D and a title and a run statement. Within the same proc G-chart code, I have a new chart statement with its own title. And so I can change within the same procedure, I can change the title by placing the run statement after that particular chart. Okay, so I could have done all of these really in a single G-chart procedure. You have to be careful though, so sometimes this is a good idea to break things apart. But so in this first, I'm doing a vertical bar chart that's 3D for each program, so that means I'm going to have 2 bars. I'm going to have the score as the mean, and I'm going to print that mean on the chart. Now, block chart isn't quite as sophisticated as it might sound here, and so we have type equals mean and summary variable is equal to score, and we're suppressing a heading. So let me take this code and submit it. So this is the 3D vertical bar chart, or VBAR 3D is the code, and so in black and white, as you likely see this in the book, it doesn't look quite color helps. Alright, but just because we can do 3D doesn't mean we always should, and so this gives us a little bit of a different image if we do like this effect of the 3D. So it's just what we had previously. I don't have that blank space here. In the next one, for a block chart, I said I don't think that's quite what we were hoping for here. And then also we said no heading, because it would have put then in here it said block chart of program, and so there would have been an additional line here. But again, here we have a lot of space. The block charts aren't too helpful in my opinion, because there's no vertical axis to measure those bar heights, and so it's very difficult to get a feel for how extreme some of these measures are, and where they sit, is that supposed to be at 0, that sort of thing. So they're a little harder to tell. I don't know that they're all that meaningful in this application. And then the last thing that we can look at is a pie chart. We all know what pie charts are, and so that if we wanted to produce a pie chart for the percent of students in each of the programs, we already know there's 16 and 14 in each of the programs, and so if we just look at a pie chart, type equals frequency is the default, but let's say percent here, and run this. So this percent of program, that's the heading. That's what we're not getting on that block chart in the previous objective. As we suppress that, we can suppress that in the pie chart using a no heading option. Refer to table 5.1. And program A is in the top part of this pie chart with 46.67% and 53.33% below. Now with only 2 levels, a pie chart's not all that exciting. Okay, but if we would have had more levels of program, then we'd have more wedges of the pie here. If the program values were numeric, we would need a discrete option also to get the right number of slices in the pie, and or to get them labeled correctly. So we wouldn't want really obscure numbers for wedges in the pie chart. We'll learn more about color in later chapters, because if you take this to black and white or grayscale and you try to print this, you may end up with just a big black dot if you were to print things. We'll learn about color and pattern options coming up later on in the book, where we can really make some of these look much, much better than the default image. One of the big lessons here, that as we're getting started in our programming now, is that what can we put in a program? Okay, so you've been watching me cut and paste all this together, so I have a data set created at the top, and then I can run all these procedures. I just keep stacking them up, and that works well. So I could run this program all the way, or submit it all the way top to bottom, not highlighting it as I have been, and that program would run. The one thing I might want to do is start up at the top and put in the display manager commands, where we had the dm log clear. I've been looking at results viewer, so I want to clear the results viewer using the ODS results clear commands, and then reset the titles, and you can reset the footnotes if you're using those also. Okay, and we may add some more lines up here at the top that are just kind of housekeeping kinds of statements. All right. You also see that I have a single line comment. I've referred to those before. Again, see Chapter 20, Section 2 for information about comments. So that this instruction dataset.sas is the name of the program I had that just created this dataset. So I can change this program here to the name of the program so I know how I've got it filed on my I can change this over to Chapter 5 objectives.sas, so I know this has all of the Chapter 5 objectives in it. And so we could run this all the way from the top and produce all of those images, but this gives you a feel for all of the different things we can put in a single program. Notice this enhanced editor is drawing these horizontal lines in between blocks of code that go together. One question you might have is, do I need a run statement in every one of these? Here, yes, you do need those to change the titles, but the run statements for each G-chart procedure are not necessary. All that's necessary is you have one down here at the end, and I've got too many quit statements in here, so let's go ahead and take that one out, with your last line being quit. Okay, so this is how you kind of start building the programs. And can you change or introduce a new data set at any point, a new data step? Yes, you can. And so that they don't all have to be G-chart procedures. We could look at things where we've seen any of the previous procedures. They could be inserted in here. So the thing to be careful of is that you don't want to start another procedure in the middle of a block of code that's identified as lines that go together for that procedure. So you don't want to interrupt that with another procedure. So just some general guides then on how we write a program, and there's no right or wrong way. If you've developed a uppercase lowercase system you like, that's fine. If you like indenting lines or putting in other blank lines or leaving them out, your style is your style. So this is basically how I do it. The uppercase and lowercase, I'm following along with the book so that you know what's our SAS statements and which things then are changeable for us. Typically when I program, I leave the caps lock key off, and most of my stuff then is all lowercase in practice. But for purposes of this course, I keep the uppercase lowercase consistent with the textbook and consistent with SAS documentation. That's all for now. We'll see you in Chapter 6.